Good day, everyone. In this presentation, I will review the research study titled Simulation Model for Determining Civil Engineering Project Earliest Finishing Time. So this work was published in 2024 and focuses on the application of simulation techniques to improve the accuracy of predicting construction project timelines. So I am Engineer Naomi Eloisa Anifa, and again, good afternoon. So this paper review is a partial fulfillment of the requirement for the subject modeling and simulation of engineering systems. Okay. So let's proceed to the content of the presentation. So we have 7 important content. First is who have done the work. Second, what were their goals and objectives? Third, what were the research questions, if any? And fourth, what were their methods in terms of, but not limited to? What were their findings? What were the gaps in their studies or findings? What is your takeaways on the research paper? So let's proceed to the first content of the paper review, which is who has or have done the work. So this research was conducted by 5 authors from various international institutions. So first is Eberchukwu Dixon Haru. Third is Emmanuel Ogunjufor. Third is Shinedu Kingsley Ashuki. Fourth is Emmanuel Emeka Okafor. And fourth is Daniel Eberchukwu of Uzu. So these researchers are affiliated with universities in Nigeria, China, and Kazakhstan, giving the study a diverse academic background. Second is, what were their goals and objectives? So the main objective of the study was to develop a comprehensive simulation model that could accurately estimate the earliest possible completion time of civil engineering projects. So more specifically, they aimed to, first is overcome the limitations of traditional scheduling methods, such as the critical path method. Second is integrate Monte Carlo simulation and agent-based modeling to capture uncertainties in construction work. Third is produce a probability-based timeline rather than a single deterministic schedule. And last goal or objective is to provide a tool that improves project planning or forecasting and risk management. So what were the research questions? So although not stated explicitly, the study clearly focused on answering these questions. First is, how can simulation techniques improve the accuracy of predicting the earliest finishing time of civil engineering projects? Second, can a hybrid model, Monte Carlo plus agent-based modeling, better capture uncertainties compared to traditional scheduling methods? Third, what risks and uncertainty variables most significantly affect project duration? Fourth, how reliable is the model when validated against historical data? Next, what were their methods in terms of but not limited to? So under methods, we have 3 different questions. So first is, how did they gather data? Second, how did they form the data set? And third, how did they process the data? In how did they gather the data? We have 3 important questions to answer. First is, who are the participants? So there were no human participants. Instead, data involved past civil engineering projects and expert input from industry professionals. How is the data gathering set up? So the data was gathered from multiple project sources, then reorganized into activity lists, durations, and dependencies. Third, what are the tools or techniques used in data gathering? So they use several software tools such as Whisk for Monte Carlo simulations, AnyLogic for agent-based modeling, and Excel with Whisk add-in for PERT distribution modeling. So how did they form the data set? So the data set was built using a sample two-story building project with 14 activities. Each activity assigned minimum, most likely, and maximum durations, uncertainty variables such as weather, learning curve, crew absenteeism, space congestion, design changes, and labor unrest. How did they clean the data? So data cleaning included removing incomplete or inconsistent entries, standardizing activity durations, ensuring logical activity dependencies, and validating uncertainty ranges for PERT distribution. Next, how did they process the data? So data processing took place in several stages. So first is the model development, which the authors created a hybrid simulation model combining Monte Carlo and agent-based modeling. Next, simulation execution. They ran simulations using 100 iterations, 500 iterations, and 1,000 iterations. Each iteration generated different project duration outcomes based on random sampling. And last is analysis. So for analysis, we have probability of finishing within certain days, narrowing ranges of completion times, sensitivity analysis to identify the most delay-sensitive tasks, and validation by comparing outputs with actual historical project results. Next, what were their findings? The major findings include the earliest finishing time. So across all simulation stats, 100, 500, and 1,000 iterations, the model consistently produced a most likely and earliest finishing time of 225 days. Probability-based completion. About 90% probability to finish within 225 days or 100 iterations. Higher iterations produce a narrow range of 222 to 230 days. Next is the uncertainty effects, superstructure, painting, plastering, foundation, and roofing. And lastly, the model reliability. The PERT distribution and triangular distribution both produce consistent results, showing that the model is stable and dependable. So what were the gaps in their studies or findings? The limitations identified include, first is dependence on estimate accuracy. The model is only as good as its input. No real-time data integration, so the results can be improved with IoT or BIM real-time feedback. Only one project type simulated. A two-story building may not represent large-scale projects. Assumption of independent tasks. Are real delays often cascade or correlate? And some uncertainty variables were not supported by big data sets, only expert judgment. So what is my takeaways on the research paper? So my personal takeaways were simulation is far superior to traditional scheduling because it accounts for uncertainty. The integration of Monte Carlo and agent-based modeling provides a realistic, probabilistic forecast for project completion. The consistency of the 225-day result shows that simulation helps identify a trustworthy earliest finishing time. The study emphasizes that good estimation practices remain essential, like output quality depends on input quality. And sensitivity analysis helps project managers focus on critical delay-sensitive tasks, making scheduling more strategic and efficient. So my conclusion, In conclusion, this research successfully demonstrates how advanced simulation techniques can significantly improve project scheduling accuracy in civil engineering. The project or the model developed is a powerful tool for predicting timelines, managing uncertainties, and guiding project managers toward better planning and execution. So thank you for listening and good afternoon.